do a moving vehicle, a s'more, and a person losing weight all have in common? The three don't seem to go together unless you're looking at the chemistry. And these examples involve the chemistry of combustion, or burning. First, let's look at the most important example to our health and happiness, the s'more. Ever eaten a s'more with a cold marshmallow? Trust me, don't try it at home. It's like chewing on a lemon instead of drinking lemonade. Don't try that either. Anyway, the key to a good s'more is fire. Let's look at the basics of combustion. In order to start a fire, you need fuel, oxygen, and heat. The fuel is usually a hydrocarbon. Put your chemistry hats on. What elements are in a hydrocarbon? Yes, you smart cookie, hydrogen and carbon. Fuels can also contain oxygen, like in alcohols or sugars. So, we need a hydrocarbon and oxygen and lots of heat. But what do we get? You get the two best known compounds containing carbon, hydrogen, and oxygen: carbon dioxide and water vapor. But wait a minute, you say. Those products are both colorless gases. So why does my fire always look like this? The equation we discussed is complete combustion, kind of like the best scenario. But oftentimes there's not enough oxygen for complete or perfect combustion. So another side reaction occurs called, you guessed it, incomplete combustion, which looks like this. The smoke coming from your fire is solid carbon, also known as soot. There's another type of incomplete combustion as well. Let's look at the car. The engine is burning gasoline, a mixture of hydrocarbons, to make carbon dioxide and water vapor. The equation might look like this. But there's another colorless killer at play here. Incomplete combustion also leads to the formation of carbon monoxide, a colorless, odorless gas that your red blood cells mistake for oxygen. They pick up and carry around carbon monoxide like oxygen, but they can't let it go, inactivating your red blood cells by plugging them up and eventually killing you. Smokers are always inhaling some carbon monoxide, making it hard for them to exercise. So avoid smoking and secondhand smoke. Go home and make sure that you have a smoke and carbon monoxide detector in your home, since the poisonous gas can also be formed from regular home appliances if they malfunction. Still don't think this is useful chemistry? Fine, here's a bonus chemistry magic trick to keep you kids happy. Prepare a solution by pouring some rubbing alcohol in a glass along with some table salt. Find a guest, parent, or kid sister with some spare cash and ask to use it for your magic trick. Soak the bill in the solution. Take it out with some tongs and light it on fire. Sodium and table salt burns bright orange, so the money will go up in a bright flame. This should be short-lived, however, so that you can hand your guests back their money unscathed. Or keep it, whatever. Why does this work? Alcohol is an excellent fuel. When you light the bill on fire, the alcohol goes up in flames, just like when a chef flambés. Normally, once the alcohol has burned up, the paper would follow. Rubbing alcohol is a mixture containing mostly water though, so once the alcohol is gone, the bill is still soaked in water, keeping it from certain demise. From personal experience, I should advise you to ensure that you soak the bill very well though, so that you don't end up handing back cash that looks like this. Back to the beginning. Where does exercise and weight loss in biology fit in? Your body is burning fuel all the time, often in the form of sugars, which look like this, and burn to form water vapor and carbon dioxide. Lots of people think that when they're burning fat, it leaves their body as energy. They're concerned with how much energy they consume and burn. They're right that the key to losing weight and burning fat is moving more and eating less. But what actually happens to the fat in your body when it burns? Well, let's look at our equation. Don't let the complicated numbers fool you. It still becomes water and carbon dioxide. You breathe that fat out. Mic drop. True story. The lesson? The chemistry of combustion, and especially s'mores, are an important part of life. So, let's learn it.